All right. Hi, Sako Kechukwu. Evening. Hi, Robinson. Obedient. You are here. You're welcome. Okay, please, can you see the two lines on the board? Please, can you see the two lines on the board? I'm using it to do the marcation so that I'll be sure you can see everything I'm writing. If you're online, say hi, please. Let's know who and who that's are with us before we start. Onwuka Christian, okay, you're welcome. Support Kichku, you're welcome. Robinson, you're here. Okay. Evelyn, you're welcome. Okay, Bridget, you're welcome. That is Kewe, you're welcome. I see you. Okay, so we're going to look at circular motion. All right, so we can start. Good afternoon, everyone. You're welcome to today's class. So what we're going to look at now is circular motion, okay? So if you look at circular motion, we still remember rotational motion. Anything that happens in a circular form is said to be circular motion, and it's also said to be rotational motion, okay? But in circular motion, there are so many things that are kept into consideration, different from rotational motion. So let's get into that.
Once you plenty, no space for her. So you need to come out where. You understand? You need to come out where. What you do, let me use it.
Usechus, thank you for coming. Suguma, thank you for coming. Thank you so much. Oyeka, thank you so much for coming. The topic for today is circular motion. Circular motion. Eagles Corner, thank you so much for stopping by. Kingsley Eze. Okay, please copy what you have on the board. Please double tap on your screen. Thank you so much. Let's dive into circular motion. Okay, class. So let's get into circular motion. Circular motion, an object moving with a constant speed along a circular path is said to have uniform circular motion. An object moving with a constant speed along a circular path is said to what? Have uniform circular motion. What do I mean by that? This is a circle and a particular object that has a constant speed, that means speed is constant. If it takes an object 100 meters per second to move around this circle and it becomes constant, that object is said to go circular motion. Do you understand? Okay, so that is the difference between circular motion and rotational motion. In rotational motion, the motion does not have a constant speed. For example, the rotation of fan blade is an example of rotational motion. But we can decide to use our fan regulator to reduce the fan or to increase it. But we can't say that the motion, the speed is what? Constant. Why? Is because when you consider constant motion, for example, I said the earth moving around the sun, and it takes 365 days for it to complete 1 year, and it also takes 24 hours for it to complete 1 day. So that is what I mean by constant what? Speed. So it continues like that till eternity. So such motion is said to be under circular what? Motion. Okay. All right. If I give an example of rotational motion, the motion of what? A merry-go-round. A merry-go-round is an example of rotational motion, but it cannot be classified as circular motion because the speed is not constant. You can stop the movement, you can still continue with the movement, so it's not a constant speed. Any motion that has a constant speed should be considered as circular motion, okay? But anyone that does not have a constant speed should be considered as what? Rotational motion. But all takes place in a circular path. Do we understand? Okay. So I have one, the moon, the earth, the planet moving around the sun, and the earth moving around the sun. So all these are a constant phenomena that takes place with a constant speed. So that is why they are classified under circular motion. I hope you get that. All right. Now, Robinson, this is SS1. Okay, please copy what you have on the board and give it a thumbs up. Let's explain further. Yes, Evelyn, this is XS1 class. Which class are you, please, Evelyn? Which class? Voice Connect UG. Hi, hello, you're welcome. Thank you for stopping by. All right, are we done writing? Please let me know. Pekuli, are you done? Ifeoma, are you done? Mbamba done, you're welcome. Please give it a thumbs up. You're welcome. Connect UG, you're welcome. Thank you. Thank you, Tania's Babs World. You're welcome. Thank you for stopping by. I appreciate. Please give it a thumbs up. God bless you. Pekuli, are you done writing? Tania's Babs World. Thank you for stopping by. All right. Esther Frank. Is that Emmanuel or Emanuela? You're welcome. How are you? Okay, so we are done. We can move into another part of the topic. All right. Emmanuel and Emanuela, you're welcome to today's class. I see both of you. Remember, you're not yet done. But can you see the board clearly? All right, so let's move in. All right, Treasure, you're welcome. Please copy what you have on the board, please. If you are here and you have not subscribed, make sure you subscribe. Okay, and give this live a thumbs up. Are we done writing? Nkiru, you're welcome. Benita, Ihunda, you're welcome. Are we done writing? Okay, you have a few minutes to do that. Let's just explain. Osai Blessing, you're welcome. Now, are we done with what we have on the board? Okay, let me explain. The speed of the object is constant in magnitude, but its direction is changing in a uniform manner. Let me do a recap. The speed of the object is constant in magnitude, but its direction is changing in a uniform manner, okay? The velocity of the object is therefore changing. Since acceleration is defined as the rate of change of velocity, then a change in the direction of velocity constitutes an acceleration, just as does a change in what? In magnitude. Now let me explain this statement. It means that for a body to be in circular motion, its speed must be what? Must be constant. It's moving with a constant speed. But the direction is changing because it will move to cover a circle and return back to itself, right? It moves this way. So as it's moving, its speed is what? Constant. But the direction is changing. And because speed is a scalar quantity, it does not have direction. So it can only have magnitude, but it does not have direction. So because it is changing, it now constitutes an acceleration. Sorry, it constitutes a velocity which has a direction, okay? And that same velocity constitutes an acceleration, which is also taking in place when we are moving in a circular path. Let me go again. I said that speed is constant because speed is constant, but its direction is changing. But speed is a scalar quantity. It does not have direction. It only has magnitude. So as it's moving in a circular path, we now involves what? Velocity. And velocity has what? Direction, because it's a vector quantity. Okay? So as the velocity is moving in a circular path and the direction is equally changing, the velocity consists of what? Acceleration, because we use velocity to derive our what? Acceleration. So it constitutes an acceleration which is also directed towards the center of this circle. And that acceleration is what we say to be what? Centripetal acceleration. I'm going to explain that after this one. I hope they are clear. Evelyn, can you see now? All right. Are you done writing? I just want to explain. Let's go into another one. Please, you have to concentrate. That is why you are here. If I see that you are not serious, I will remove you. This final warning. Concentrate and give me my response. Once you are done, let me know so I can proceed. Are we done writing? Ifeoma, you are done, yes? Peculiar, are you done? Ella Frank, are you done? Kewe, are you done? Mbamba, you are done, okay? Essien done. Alabo done. Okay, so I should proceed. Please copy what you have on the board. Let me explain. Are we done? Onwuka Christian. Tawish, you are welcome. Thank you for coming. Okay, this is your level. You can learn with us. You're welcome. Please give it a thumbs up. Evelyn, are you done writing? Okay, you're done. Evelyn, you're done. Bamba done. Okay, we are done. Okay, let me explain. I was saying that the speed of a circular motion is always constant, but its acceleration is what? Its direction is changing rather. And as this direction is changing, the body is moving towards the center of the circle, okay? So it constitutes a velocity, which constitutes an acceleration because we use velocity to derive our acceleration. So that acceleration is what is said to be centripetal acceleration because this acceleration is moving towards the center of the circle. All right, let's proceed. This acceleration is directed towards the center of the circular part and is known as centripetal acceleration. Okay, this acceleration that is directed towards the center is known as centripetal acceleration, and its magnitude, this is A for acceleration and the base T for centripetal, now is given by v square over what? R. The magnitude of centripetal acceleration is v square over r. What is v? Near v is velocity, or classified as speed, and r becomes what? Radius. Now I want to explain this diagram. Now if the body is moving in a circular path, I say that the speed is constant, but the direction is what? Changing. As the direction is changing, it is moving towards the circular path. Now it is moving towards the center of what? Center of the what? Of the circle. Now this velocity constitutes an acceleration, and this acceleration is also moving towards the center of the circle. So this acceleration that is directed towards the center of this circle is what is said to be what? Centripetal what? Acceleration. Now this acceleration we are talking about constitutes a force which is also directed towards the center of the circle, because we should know that force is a vector quantity. It has magnitude as well as direction. So this acceleration that constitutes a force, the force becomes what? Centripetal force. So let's dive into that. Eze Kingsley, are we done? You're not the only one learning. Everybody is learning. So concentrate on the board. That is why you are here. Okay? Do we understand? If you understand, let's move into what we have. Are we done writing? Kingsley done? Mbamba done? Ifoma done? Peculiar done? Kewe done? Ella Frank done? Osai, you are done. All right. Alaba done, okay? Evelyn, you're not seeing my handwriting. Actually, it's not from your network. Okay, I'll read it out. In a circular path. In a circular path. Okay? Remember, in a circular path. Washington blessing, you're not seeing the board. Maybe you should check your network. Treasure. Okay, treasure. Listen, can you see it now? So let's explain what we have. This inwardly directed acceleration leads to a force known as centripetal force, which is also directed towards the center of the circle. Okay? This inwardly directed acceleration led to a force known as centripetal force, which is also directed towards the center of the circle. Now, why is this acceleration directed towards the center of the circle? Because acceleration is a vector quantity and it constitutes a force, and force is also a vector quantity. So both of them are directed towards the center of the circle. As the body is moving in a circular form, its velocity is directed towards the center of the circle, the acceleration is directed, and the force is equally directed towards the center of the circle. Okay? Now let's go. Centripetal force, the symbol is Ft. F base T is defined as that inward force required to keep an object moving with a constant speed in a circular path. Let me go again. Centripetal force is defined as that inward force required to keep an object moving with a constant speed in a circular path. Okay? Now the centripetal force is given by Ft equals mv square over r. Ft is equals to mv square over r, where m is the mass, v is velocity or speed, and r is radius. Do you understand that? Do we understand? If I may say I don't understand, okay? Bamba, I don't understand. Kewe, do you understand? Hezekiah Effion, you're welcome. Just coming. You're welcome. Treasure, you understood, okay? If you are just joining us, make sure you subscribe and give this live a thumbs up. Mbamba, do you understand? Kinsilieze understood, okay? Ella Frank, you don't understand. Okay, let me explain again. I said previously in the other diagram that we drew, we said that anybody that undergoes circular motion is moving what? In a circle. And for it to be a circular motion, it must have a constant speed. And I equally gave you the difference between circular motion and rotational motion, okay? That rotational motion, there is no constant speed. You can regulate rotational motion. But in circular motion, there must be constant speed. Now, as this body is moving in a circular path, even though that the speed is a scalar quantity, and the speed is also constant, the direction of the motion is what? Is changing, and it's changing in a uniform manner, okay? So as the direction is changing, it also constitutes a velocity, and velocity is also what? Changing. And as it's changing, it is being directed toward the center of the circle, and it constitutes an acceleration called centripetal acceleration. And this centripetal acceleration is being directed toward the center of the circle, okay? Now, this centripetal acceleration is an inward acceleration, Now it constitutes a force which is called centripetal force. This centripetal force is also directed towards the center of the circle. And I said that centripetal force is that inward force required to keep an object moving with a constant speed with in a circular path. So this particular force that is going to help us to keep a body moving in a constant speed in a circular path is said to be centripetal force. And its magnitude is given by is equals to mv square over what? R. What does M stand for? Mass. What is V? Velocity or speed. What is R? Radius. Is that clear now? Okay. Oh, okay, Christian, you can copy now. Okay, understood. Peculiar, understood, okay? Peculiar, say you don't understand. Rosemary, understood. All right, are we done writing? Let's proceed. If you are just joining us, please give it a thumbs up. Are we done writing? So we can solve problems. Are we done? Let's solve problems. Oh. Oluchian, you're welcome. Peculiar, SN. You say we can proceed? Okay, do you understand it now? Maybe by the time you solve one or two problems, be able to understand. Do you understand it now? Baba, I thought I gave you people assignments yesterday. I did. I gave assignments yesterday. Okay. But if you did not see the assignment, you can check on the video frictional force calculations. You see the assignments, okay? Estienne, let's just solve one or two problems. I believe you understand better. So we can proceed, okay? Estienne, are you sure it's not for your network? Okay, let's try this example. See, you're not seeing the two lines. Check this from your network. You can change your position. Okay, so let's look at this example. Okay, let's solve together. A mass of 10 kilogram is moving in a circular path of radius 2 meters with a uniform speed of 50 meters per second. Find the centripetal acceleration and the corresponding centripetal force. Let me go again. A mass of 10 kilograms is moving in a circular path of radius 2 meters, with a uniform speed of 50 meters per second. Find the centripetal acceleration and the corresponding centripetal force. For us to do that, we have to state our parameters given, okay? By saying kilogram, then radius is given as 2 meters, and we have speed to be given as 50 meters per second. Okay, so the first thing we have to look for is the centripetal acceleration, and the formula for centripetal acceleration is v squared over r. I'm saying v times v, right? So I'll substitute the value by saying, what's my v? My v is 50. 50 times what? 50. That is the same thing as 50 squared. Divided by, my radius is what? 2. Okay? So I'm going to bring it down. 80 is equals to 50 times 50. I can say 5 times 5 is 25. Then I bring out what? Then I divide it by what? By 2. Okay? So by the time you divide, your answer will give you what? 1,250 watts Newton. Is that okay? So you can use your calculator to confirm that. This will give you what? 1,250 watts Newton. Is that okay? All right. Now, for us to get our acceleration, which is centripetal acceleration, is given by mv squared over r. So let's just substitute into what we have. What's my m? My m is 10 times my v is 50. I can say 50 times 50 divided by what? My radius is what? 2, right? These 2 can cancel itself to give us 1. 2 can cancel then to give us what? 5. Okay? So my FT is equals to 5 times 50 times 50. Okay? Now we have to multiply. You can use your calculator to multiply. You will say 5 times 50 times 50. So the answer will give us what? 12,500 Newton. Okay? So the answer is going to give us 12,500 Newton. So let me do a recap. We are given a mass of 10 kilograms moving in a circular path of radius 2 meters with a uniform speed of 50 meters per second. Find the centripetal acceleration and the corresponding centripetal force. Now, with that being said, let us bring out the parameters given. My mass is given as 10, my radius is given as 2, and my velocity is given as 50. Now, remember my formula for centripetal acceleration is equals to v squared over r. I will substitute it into what I have and get my what? My answer. Is that okay? All right. Now, for my centripetal force, I have to input the formula, which is mv squared over what? R. Then my mass is 10 multiplied by the velocity divided by what? By the radius. Okay? I will divide this to get 5. When I multiply all through, I have 12,500 Newton. Is that clear? All right. Mom, I said the board is not clear. Evelyn is not clear. Aisha is not from your network. My own is clear. Check your network and check your location, please. But that's why you're not seeing the board. It's okay now. It's network. It's network. Okay, it's clear now. Rosemary, it's network. All right. Please, do you understand the explanation or should I explain again? Should I explain again? Okay, let me explain again. All right, a mass of 10 kilogram is moving in a circular path of radius 2 meters, right? Okay, with a uniform speed of 50 meters per second. Find the centripetal acceleration and the corresponding centripetal force. Now, for us to do that, we are going to state our parameters given. We are given the mass as 10 kilogram. That is that. We have radius as what? 2 meters, right? Then we have velocity, which is the same thing as the speed, as 50 meters per second. Now, what do we do next? We remember the formula for centripetal what? Acceleration, which is at is equals to v square over what? R. Now, what is my v? My v is 50. V square is the same thing as saying v times what? V divided by what? 2, because my radius is 2. What do I do next? I multiply. 50 times 50 is 2,500. Then divide it by 2. And my answer becomes 1,250 Newton. Sorry, this is not supposed to be Newton because acceleration is measured in meters per second. So this is 1,250 meters per second as the acceleration. Okay, so for us to get the centripetal force, our formula becomes mv square over r. All right, what is my mass? My mass is 10. I have 10 times my speed is 50. That is 50 square. So I have 50 times 50 divided by my radius is what? 2. Okay, if 2 should divide itself, it's going to give us what? 1. Okay, if 2 should divide 10, it's going to give us 5. So what do we have? We say this is 5 times 50 times 50, right? By the time we multiply it with our calculator, we are going to have 12,500 Newton. It becomes what? 12,500 Newtons. I hope you are clear. All right. Treasure, do you understand it again? Do you understand? Is it cleared? Okay, Mama, say why is it ms minus? That is unit of acceleration. I made mistake earlier, so it was supposed to be meters per second square. Okay, it's supposed to be meters per second square. Okay, blessing, you understand? Thank God for that. Okay, are we done writing? Are we done writing? Yes, I have SS3 today by 4 p.m. Okay, so once we are done, I will start SS3 class. Okay, let's go move to another one. All right. I want you to look at this example to see how you can be able to solve it. All right. Try this one. Let's see what you have. So sorry, network disturbance. So sorry. You can check your location. Okay. Okay, acceleration is 6.75 meters per second square. Okay. Then the scheme of work for which class? Scheme of work for which class are you requesting for? Okay, SS1 scheme of work. Okay. Rosemary 6.75 meters per second square. Okay, Mbamba 101.25 Newton. Okay. Yes. Peculiar, Ella, Kewe, treasure. Okay, allowable 6.75, okay, meters per second square, okay. Kewe, where are you? Ella. Treasure, where are you? Send in your answers. SS1 scheme. How do I send it to you? How do I send the SS1 scheme? I should snap it. Okay, are you from are you in Port Harcourt? Are you in Abloma? Aloze from 101.25 Newton. Ella Frank 6.75 acceleration. Okay, Dimaya from Abloma. Okay, so I will send it on the group now. Not now. When I'm done later in the evening, I'll send it on the group. Okay. All right. Remind me. Okay. Rosemary 101.3 Newton. Okay. Kewe, where are you? One 101.25. Okay. All right, so let's do correction. Let's see if we are all correct. Okay. All right, let's look at this example. An object of mass 15 kilogram moves with a speed of 4.5 meters per second in a circular path of radius 3 meters. Calculate its centripetal acceleration and the centripetal force. Is that okay? An object of mass 15 kilogram moves with a speed of 4.5 meters per second in a circular path of radius 3 meters. Calculate its centripetal acceleration and the centripetal force. So the first thing you're going to do is for us to state our parameters. And what are the parameters? My mass is given as 15 kilogram. Okay. My velocity is given as 4.5 meters per second, and my radius is given as 3 meters. Now, what we need to do now is to set our what? Our formula. The formula for centripetal acceleration is equals to v squared over r. Okay, so what is my velocity is 4.5, right? I can say 4.5 times 4.5, right? Divided by what? 3. Okay, so we use our calculator to say 4.5 times 4.5. So I have 20.25. Then I divide both sides by what? By 3. Okay. I'm going to have my acceleration to be 6.75 0.75 meters per second squared. Okay. Now let us solve for centripetal force by saying F is equals to mv square over r. F is equals to, what's my mass? My mass is 15 multiplied by the velocity is 4.5 times 4.5, right? And divided by what? By 3. Okay. Now this 3 can cancel itself to be 1. It will cancel 15 to give us what? 5. So what we need to do now is to say 5 times 4.5 times 4.5. Okay. Now with the help of calculator, we say 5 times 4.5 times 4.5. My answer to this question is 101.25 Newton. Do we understand? So we are correct. We got our acceleration at 6.75 meters per second square, and our force to be what? 101.25 newtons. Is that clear? Okay. Okay, so we can proceed. You might say your WhatsApp is not working. That means you have to send me a message on YouTube so that I can forward it to you. Oh, I thought we ought to approximate, but noted. No, we don't. You don't approximate until you are done. You don't approximate. Even if you can still approximate to say 101.3 Newton, you are still correct. Because this is your final answer. Okay? You can still approximate to say 101.3 Newton. You are still correct because this is your final answer. You understand? All right. Yes, Rosemary, you are correct. Okay, so let me give you the last one for today. I want everybody to get it. right, you can check out this example. Let's see. It's not assignment, it's class, it's not assignment, it's classwork, okay? So just solve it so we can go. I want you to try. I'll give you a few minutes to try, okay? Try and see if you can get the answer. Bamba said I should ask Sarah's dad. Okay, you can send the number and the group. Okay, so I'll add him. All right. Okay, are we done? Are we solving? Are we solving? Are we solving? Who is done? You can send in your answer. Who is done? Yes? Send in your answer so that we can go for today. Yes. Okay, let me solve. Okay, blessing done. What's your answer? What's your answer, blessing? Ella, are you still there? Okay, are you still there? Are we still there? Okay, for the sake of my time, let me solve, okay? All right. The question says, a body weighing 100 Newton moves with a speed, okay, of 5 meters per second in a horizontal circular path of radius 5 meters. Calculate the magnitude of the centripetal force acting on the body. You get the question? A body weighing 100 Newton moves with a speed of 5 meters per second in a horizontal circular path of radius 5 meters. Calculate the magnitude of the acceleration of the centripetal force acting on the body, and we are giving G as 10 meters per second square. Now, for us to be able to solve this, we must know one thing. Let's get the parameters. We are giving the force. We are giving the force. Are we giving the force? We have a body weight, so we are giving the weight. The weight of the body is what we are giving. As we are giving the weight, and the weight is 100 Newton, and the speed is 5 meters per second, okay? And we have radius to be 5 meters, right? Okay, so what do we do? And we are giving G, which is acceleration due to gravity, to be 10 meters per second square. So what we need to do now, we don't even have the mass, so we can't solve for centripetal force. We are going to get the mass, okay, by saying that weight is equals to mg, and we did that yesterday. That weight is equal to reaction force, and weight is acting downwards, and weight is also equal to mass times acceleration due to gravity. That is mg. So with that being said, we now say that my weight is 100 Newton is equals to, I'm looking for mass multiplied by what? By acceleration, which is 10. So I divide both sides by what? By 10. This cancel this, right? Therefore, my mass is equals to 100 over what? 10. 0 cancel 0, right? So my mass is 10 kilogram. Okay? So since I've gotten my mass to be 10 kilogram, the next thing I'm going to do is to solve for centripetal what? Force. And the formula for centripetal force is equal to what? Mv square over what? R. Okay? Now, what is my m? My m is 10 times velocity. My velocity is what? 5. I will say 5 times what? 5, because this is v square, right? I divide both sides by what? By radius, which is what? Which is 5. Do we understand? So by the time I cancel this, 5 cancel itself. So my centripetal force is equals to 10 times 5, which is going to give me what? 50 Newton. Do we understand? Okay. Please, do we understand? I'm done solving. I want to end this class now. I just want to give you an assignment. Do we understand? So copy fast. You have a few minutes to go. Blessing, I just finished explaining. Do you understand? Okay, Blessing, I will explain again. Okay, Kingsley said I should come again. Blessing, you understand? Blessing, what be who you understand? Blessing or side, so I should explain again. All right, let me do just that. Okay, let me explain. I said that a body weighing 100 Newton moves with a speed of 5 meters per second in a horizontal circular path of radius 5 meters. Calculate the magnitude of the centripetal force acting on the body, and we are given acceleration due to gravity g to be 10 meters per second square. Okay, now when you see this type of question, what are we going to do? They give us the weight of the body. We don't even have mass, so we can't even solve for centripetal force without mass. So what you are going to do is to say that our W, which is our weight, is equal to 100 Newton, okay? Then my speed is 5 meters per second, and my radius is equally 5. Now what do I do next? I was given acceleration due to gravity G to be 10 meters per second square, okay? Now, weight, from the friction we did yesterday, weight is equals to m what? Mg. So what is my weight? I'm giving weight to be 100 is equals to m times 10 because I'm looking for the mass. So I divide both sides by the coefficient of m, which is 10. Okay, so 10 cancel itself. I'm left with what? M. Now this is equals to 100 over what? 10. By the time 0 cancels 0, my mass is equals to 10 kilogram. Now, with that being said, I've gotten my mass. I will now proceed to solve for centripetal force. My centripetal force Ft is equals to mv square over what? R. Okay. What is my mass? My mass is what? 10 multiplied by what is my velocity? My velocity is 5 because it is squared. I will say 5 times what? 5. I divide by the radius, which is equally given as what? 5. Okay. So if 5 should cancel itself, it's going to give us what? 1. So we are left with 10 times 5. By the time you multiply 10 by 5, you're going to get the centripetal acceleration, the centripetal force to be what? 50 Newton. Is it clear? All right, so I want to give you assignments that you can solve and drop your answer in the comment section. Let's say you got 500. No, you can't get 500 because are you sure you converted the weight to get the mass? The only way you can get 500 is by solving with the mass as 100. Okay, so look at it again and check your answer. All right. Okay, so I just want to give you an assignment so that we can go. I have SS3 right now. Their time has already started counting. I'm already late. All right, that is your assignment. Okay, you have few minutes to copy. Please copy it fast. Let's go. I want to end the class. My SS2 students are waiting. My SS3 students are waiting already. Are we done writing? Treasure, are we done writing? Hello, are we done writing? Okay, are you done writing? You're welcome. All right, we are done. Peculiar done. Peculiar done. Are we done? All right, so we are going to see tomorrow, same time. You're welcome. Eze Kingsley, you're welcome. All right, see you tomorrow. All right, class, thank you so much for staying to the end of this class. I bet you that if you continue doing like this, studying hard, you're going to be sure that physics will be an interesting subject for you. Okay, the more you solve, the more you understand physics better. You have come to the end of this class. See you next time in my next class. Bye.